Welcome back to SBR physics classes. Dear students, hope you are taking care of your health along with taking care of your study also. Let's start from where I left in the last class. From there, I'll continue. Okay, today's initial concept that I am going to start is resolution. Resolution, right? Let me start. Here, you already learnt in the earlier classes as we apply pressure on the ice, then the melting point of ice will decrease. This you already learned it. If you apply more the pressure than the normal pressure, then the melting point of ice will decrease. Right? Okay. With that concept, we'll start now. Okay. To understand this, let me go with an example. Suppose this is the wheel of cart or vehicle. As it rolls over a ice, as it rolls over the ice surface, then because of the weight of the wheel, pressure at the beneath of the wheel will increase more than the at 1 atmosphere. So ultimately, because of higher pressure at the beneath here, at the below the wheel, because of its weight, pressure will become more. As pressure becomes more than the 1 atm, then definitely ice melts, right? So ice melts here. Then as this rolls forward, that ice melts. Then ultimately water forms. So that as it rolls, that water will stick to the wheel. Then as it rolls forward, then definitely this so formed water here, so it will stick to the wheel, and then that wheel again back to normal condition. For example, here we can say on -5 degrees Celsius, and here atmospheric pressure is 1 atm. 1 atm. So at the beneath here higher pressure. So at the higher pressure, even ice at -5 degree melts, and that water will, as it rolls, the water will stick to the rim. So water will stick to the rim. Again, this so formed water again freezes. Why? Because again this is at -5 degree and back to 1 atm. So again it refreezes, right? Here, because of higher pressure, ice will melt at, even say it is -5, ice is at -5 degree, it will melt. As the wheel rolls, the so formed water, because of high pressure, ice melts and then water forms. That formed water will stick to the rim of wheel. Again, this so formed water, again back to -5 degree. Again, the importantly pressure is 1 atm. Here it was higher pressure, it has melted. But here it is back to 1 atm. Normal condition, -5 degree. Definitely it refreezes. Right or not? This experience in cold areas like Srinagar, Simla, and those places, you might have observed ice covers to the wheels. Because of this reason, this so formed water again it refreezes, where it backs to again normal conditions. So it's if it is -5 degree and 1 atm, again it refreezes. This is the higher pressure, ice melts. Again, pressure removed here. Here, so formed water is not in higher pressure, it is at 1 atm. Again, it refreezes. You can take even ice cube, press it. If you apply more pressure, ice will melt it. Right or not? So, higher the pressure, ice will melt. If you remove the pressure, again it will refreeze. That is there. Okay. Now, what is your resolution? It is a here when we apply pressure, let me write here. If pressure is applied, ice melts, ice melts, pressure removed, pressure removed, again freezes, again freezes. This is called what? This is called Regelation. This is called Regelation. Here what? So it's make here re is again. What is this is again gelate. This gelation, or you can write here gelate. Its meaning we can call freezing. Freezing, right? Refreezing. When you apply, if pressure is applied, ice melts, and then pressure removed, again ice freezes. Right? This is called resolution. Okay. Now we'll have an experiment here for this resolution. Here, let us go an experiment here. This is one wooden block. Okay, here also we take one wooden block. Okay, this is also one wooden block. Right? We have kept here on ice slab. We have kept on ice slab. This is one ice slab. Right? Okay. Here we have hanged one wire here. This is on metal. This is on weight. On either end of this wire, we have attached two weights. Okay. What is here? At the beneath of wire, so assume this for let me take this IC is now presently at minus 5 degrees Celsius and 1 atm. 1 atm pressure, normal pressure. Okay. At the beneath of this wire, pressure is more than 1 atm. Then you have already learnt it. If more the pressure, then definitely ice will melt at even lesser temperature. At the beneath of wire, pressure is high, then that's the reason ice melts. As ice melts, then that wire will go down. It will cut the as it goes down, it will cut the ice and it will goes down, it will go down like that. Because higher the pressure, ice beneath the wire will melt it, and then wire as it goes down, it will cut its way through down into the slab. Right? Okay. Now as the wire goes down, the upper part of that wire again back to its normal condition like minus 5 degree 1 atm, then again it refreezes. As ice is below the wire, it will be at high pressure, it will melt it. Right or not? So upper the wire, again back to normal minus 5 degree 1 atm, then again it will refreeze. So as the wire comes down, it will come down, but the ice will not break into two halves, because as the wire comes down above the part of wire, again it refreezes. As wire comes down, below part cuts, because higher pressure ice melts, the wire comes down, but above the wire what will happen? Again back to normal condition of say minus 5 degree or 0 degree. Again it will refreeze because pressure is 1 atm. Below the wire pressure is more than 1 atm. Above the wire pressure is again back to 1 atm, again minus 5 degree, it will refreeze. As the wire comes down, because of this is the weight we have hanged here, that's the reason force is applied, that wire will apply force on the ice, then it creates the pressure. So below the wire pressure becomes higher than the 1 atm, so ice melts, so wire cut its way through down to the ice, As it comes down, above again refreezes. Why refreezes? Again back to -5 degree normally, and again pressure will be 1 atm. So again refreezes here, wire will come down, but ice will not cut into two halves, two pieces, because below the wire cutting, but above the wire refreezes. Again, the ice will be without breaking. It will be intact with its initial shape. Okay, this is one simple experiment. It is there in our NCRT. In theory, they will ask you explain, define resolution, and explain with this experiment. What you have to just, you can write here the points above the below the wire. What will happen below the wire? Below the wire, pressure is pressure is more than pressure is more than 1 atm, more than atmospheric pressure. So melts ice melts, right? Above the wire, okay, ice melts. Okay, you can write the wire, ice melts, the wire cuts its way through slab, through ice. Okay, above the wire, above the wire, above the wire, above the wire, ice is at normal condition. Normal means, again say, when ice is there means either 0 degree, -5 degree, -2 degree, whatever. When ice is there, that will be temperature. So ice is at normal conditions. Normal means pressure is atmospheric pressure, and temperature will be 0 degree or less than 0. Normal. Above the wire, ice is at normal condition. It refreezes. It refreezes. It refreezes. Hence, ice will not break into two pieces. Okay, it will refreeze it. This is it. This you have to just on explanation and this diagram. This will be in theory. They'll ask you for 3 months. So one of the application of this will be during skating. Okay, at that time, below the skating, suppose this is skate. Below this is the ground. Here ice cubes. Ice are there here. So because of weight of the person, below the skates, below the skate, ice will be at higher pressure and will melt. So this is ground, and this is the ice, and this is skate, ice skate. Okay. So because of weight of a person, the pressure on this ice will be more than the atmospheric pressure. So it will be melting even at lesser temperature, right? Okay, it will melt at the lesser temperature. So as it melts, here water will convert, water will form, and so formed water will act like a lubricant. So during ice skating, there is no friction at all between the skates and the ground. There is no friction. Your inertia will make you to move. Your initial kinetic energy will make you to move. So there is no loss of energy. There is no friction here. So ultimately, this so formed ice into water, that water between skates and ground will act like a lubricant. So it will make free from friction. There is no friction. If friction is not there, so you can slide very easily. So this is very useful, like melting of ice even at lesser than the 0 degree. Melting takes place because of high pressure. The weight of a skater, because of his weight, he applies more pressure and ice melts between his skates and the ground. So that formed ice, that so formed, so converted water will act like a lubricant, and then that will make him easy to slide without any friction. And that will possible. Skating is possible because of this process of melting, right? Okay, this is there. Okay, this skating is possible because of melting of ice at higher pressure. That is there. Okay, now I'll go for effect of pressure on the boiling point now. Okay, effect of pressure on boiling point. Okay, here. So here, let me take an example here. Suppose here we have taken water here, right? If we give heat, if you give heat, then what will happen? Here steam bubbles will form as we increase 60 degree, 70 degree as the temperature increases. Here steam bubbles, okay, will form, bubbles will form. Okay. Here which pressure is there here? Atmospheric pressure. Atmospheric pressure. Right? What is atmospheric pressure here? Air molecules are there here. Here air molecules are there. Air molecules, right? Okay. Now, as we increase the temperature, then as like 70, 80, 90, as we increase the temperature, then here the H2 will, what is here? H2O, they started to free from each other. Then air bubbles, will form, like steam bubbles will form. And those H2O molecules, they try to go because of the kinetic energy, they try to go H2O molecules. Because of we are giving heat, they increase their kinetic energy. H2O molecules, they want to go out of the surface. This H2O molecules, it wants to go. But as it's about to go out of the surface, it collides with air molecules. Here air pressure is there. So it collides with air molecules, again it will back to water again. So again one more molecule, it tried to go here, again it collides with the air molecule, it will come back here. So what will happen here, those water molecules, because of their agitation, vibration, they want to go up. But because of the air collision with the air, here air pressure is there. Because of that air on the surface of water, they collide and again they back to the water. Here what will happen? Here one vapor pressure is created here. What is created here? Because of this molecules, they come, they go out, again they collide, they come here. The molecules, they go out, they collide with the air particles, they again come back here. Vapor pressure is created here. What is created here? Vapor pressure. Vapor pressure is created. Now what will happen here? Here and there. Like for example, in the summer, even at 50 degree or 45 degree, you find all canals and small ponds, they dry out. They are not at 100 degree. At 50 degree only, slowly you find canals will dry out, and here and there some small ponds, and wherever water bodies are there, you will find it they dry out. It's because, so what will happen? One water molecule, they by chance, without colliding, they by chance they go. Some molecules, as they come here, they by chance they go without colliding. Not all, here and there, few molecules. So very slow process because of those few molecules without colliding with air particle. By chance they anyhow make their way and they go to the atmosphere. This is called evaporation. What do you call this? Evaporation. What is evaporation? A few particles, by chance, without colliding with the atmospheric molecules, atmospheric air particles, they anyhow they make their way and they go into the atmosphere. This is but few molecules, right? Anyhow here, full then air is there, atmospheric pressure is there, full air is there. They will not leave any molecules of water. But still here and there, some molecules which as they go out. So these few molecules over the longer time, they can make that canal to get dry. They can make some few small water bodies can dry. Some ponds, small ponds can dry out because very few particles, water particles can go. Okay, this is very few means it takes very longer time. That's the reason the ponds, canal, they take more time. Even 1/4 of summer, in that time they dry out. Very slow time they dry out. This is there. This is called what is evaporation? Very few particles, even less than the boiling point. They, by chance, without colliding with air particle, they make their way to the atmosphere, and here and there, some particles they go. It's a very slow process. Okay, this process we call it is evaporation. Few particles they can go to the vapor. Okay, even below the boiling point. This is one point. Next point. Suppose here the temperature, this evaporation can happen at even you suppose atmospheric pressure is there, 1 atm is there. Even at 80-90 degree evaporation can happen. Some molecules can go. Surface of molecules or water surface molecule can jump into the vapor. It can go to the atmosphere. That can be there even below 100 degree. But vaporization will take place. Vaporization will take place at the 100 degree, provided if pressure is 1 atm. If atmospheric pressure is 1 atm, suppose as we give heat, as the temperature of this comes to the 100 degrees Celsius, 100 degrees Celsius, then what will happen? So here the molecules which come out, this is steam, a water molecule, vapor form of water, that H2O molecule at 100 degree, energetically they come out. As they come out, the pressure due to those molecules at the 100 degree, water molecules will come out from the surface. And those water molecules pressure at the 100 degree, the water molecules which come out of the surface, those pressure due to those water molecules and even pressure at the atmosphere, they become same. They become same, then that interaction will be equal. Then at that time we can say the water molecules, whoever comes to the out of the surface, they will go now. Whoever comes out before 100 degree, here and there, very few molecules by chance they go out. But at the 100 degree, whichever molecules, so because of 100 degree, their kinetic energy is more. Once they comes out of, once they come, suppose this is a bubble, steam. Here the water molecules are there. If they comes out with high kinetic energy, no one can stop. Even atmospheric air cannot, because their pressure and their atmospheric pressure are equal. They can anyhow there make their way. So in 100 degree, provided if atmospheric pressure is 1 atm, whatever water molecules they come out of the surface, they can go out of the water, and then they creates like foggy type of appearance, and there comes the boiling. When do the boiling will occur? So the pressure created at the surface due to the water molecule, vapor form of water at the surface, vapor form of water will create some pressure. So here pressure is created by water molecule. That vapor pressure and atmospheric pressure, if they become equal, then boiling will start. The whoever molecules come to the surface, they will go to the atmosphere. So when the boiling will start? Boiling starts when vapor pressure is equals to, when vapor pressure is equals to, when vapor pressure is, vapor pressure means the molecules they come out of the surface, they create one pressure on the external atmosphere. So when vapor pressure is equal to atmospheric pressure, atmospheric pressure, boiling starts. pressure, boiling starts. Right? So here what? Vaporization means what? Vaporization. What is this? So whatever particles, what particles they come to the out of the surface, they all go to the vapor. The particles which comes out of surface comes out of, they move to the vapor. They move to vapor form. Right? All part whoever comes out of, they will go to the vapor. They will go as a like free H2 molecule. They go as a steam. Right? Okay. Now here, what is evaporation? What is evaporation? What is this? Is few particles, few, some I can say some particles at temperature below boiling point. Some particles at temperature below boiling point, they can they can they can move to vapor. Move to vapor. Not all. Some. They can move to vapor. They can move to vapor. Few. Okay, one thing you can say, evaporation process will take place below the boiling point. Right? Vaporization will occur at boiling point. Okay, when at the boiling point, what will happen? All particles which comes out of the surface, they go to the atmosphere. Then evaporation is a small process. It will take place below the boiling point. And because of evaporation, you will find it in small ponds they dry out because of evaporation. Because no ponds are at 100 degree. Because of evaporation, the ponds will dry out. Okay. So some particles at temperature below boiling point, they move to vapor. They move as a free particles. Right? Okay. So even you can say 100% evaporation occurs at boiling point. 100%. All particles will go to the atmosphere. You can another way you can say 100% evaporation is called vaporization. Vaporization means what? All particles where comes to the surface, they go as a vapor. So you can even write another point here. 100% evaporation is called vaporization. Vaporization. Right? This is it. Okay, small difference. What is evaporation? Very few particles, okay, below boiling point. Once they come out of this water surface, some particles, by chance, without colliding with atmospheric molecules, they make their way to the atmosphere, and this is how the what will happen? Some particles will go to the atmosphere. This is what you can call evaporation. What is evaporation? So all particles, they go to the atmosphere. Here in evaporation, not all particles. Very few particles will go to the atmosphere. This is it. No. So when boiling will takes place, when vapor pressure is equals, at that time boiling will takes place. Now we'll come to the effect of pressure on boiling point. This is bit basic before I come to effect of pressure on boiling point. Okay, I will continue again this heading. Whatever I explained, that will be basic for this proceedings. Okay, now effect of pressure on boiling point. Let us take one round bottom beaker. This is one beaker. No, this is let me take round bottom flask. This is a flask here. Okay. Here this is one thermometer. This is thermometer. Okay. Now here one outlet for steam. This is an outlet here for the steam purpose. Okay. Here we'll close here with the rubber cap. We'll close it. Here we completely close it here. Okay. Now here this is okay. Now here is say water. This is water. Okay. Now we are heating this water. We are heating it. Right. Okay. Very simple. As we increase the here, this outlet is what you call steam outlet. Steam outlet. As it is open, therefore, the pressure at the surface of this water and even pressure at the mouth is atmospheric pressure. So it is open means what is the pressure at the atmosphere? Pressure at the surface of water? Atmospheric pressure. Now let me write the point. When outlet one by one I'll take. When outlet is open, definitely pressure at the surface will be atmospheric. And when outlet is open, pressure at surface of water is 1 atm. Right? 1 atm. This is it. Okay. Now as we give heat, as because of water is at 1 atm pressure, when at what temperature it will boil? At 100 degree. Because the water is at 1 atm. So when temperature is 100 degree, when temperature is 100 degrees Celsius, water boils. Water boils. Because what is the pressure where that water is now? If pressure is 1 atm, then definitely always water boils at 100 degree only. This now what I will do, I will close it. I will close it. When I close it, here so formed water vapor, here steam will accumulate here only. Here water so formed vapor, when I close this, water is at 100 degree. Here water vapor is there here. Right or not? Here water vapor is there. So now we can think here, as I close this steam outlet, then pressure on the surface of water will become more. Because this so formed water vapor, they create more pressure on the water surface. Many more molecules here, more vapor is there. The more vapor, they create pressure on the water surface. As they create pressure on the water surface, we find no molecules of water can come out because they are packed. This external pressure becomes more. So water molecules, they want to come up at 100 degree. They want to come up. Now the pressure on the surface of water becomes higher than 1 atm. They are unable to come out. They press it down. So boiling stops. Okay, boiling stops. What I can, the next point you can write, when outlet is closed, what will happen? Vapor pressure increases, sorry, here external, this vapor only creates external pressure. So pressure on the water surface increases. Closed. Pressure on water increases. Water, okay, surface increases. Right? Boiling stops. You will observe if it, this is a glass flask, transparent, intentionally transparent flask is taken, you will find it suddenly, all of a sudden boiling stops. There is no boiling, you can find it. Surface increases, so pressure on the water surface, boiling stops. Boiling stops. Boiling stops. Even it is at 100 degree. Thermometer is showing 100 degree, but boiling stops. What is change has happened here? Pressure is more than 1 atm now. The so formed that vapor is there now. Here, that vapor only they start to apply pressure on the water surface, and they are not making any new molecules of water to come out. Then completely surface is sealed. Then boiling stops automatically. Then what you have to, you want to boil it, you have to increase the temperature. Further you have to give it, you have to increase the temperature somewhere at 120, 130, somewhere at higher than 100 degree, again it start to boil. So what is your boiling stops? At higher temperature, at temperature higher temperature then 100 degree, again water starts boiling, starts boiling. Now what you can understood from this, as the external pressure on the water surface increases, so it will start to boil at higher temperature than 100 degree. So we can say boiling point increases. What is the conclusion I can make here? As pressure increases, boiling point also increases. More the pressure, then you want to boil, you have to increase the temperature, right? Okay, this is one point. Next point, what we have to do? Next time what I'll do, I'll remove thermometer, I will let, and I'll just uh, turn it down like that. I'll turn it down like that. I'll completely, with the airtight cork, I'll close it completely like that. I'll close it. This only I'll turn it down. Then what will happen? I'll leave it for some time. Like I'm not heating now. This only I'll just turn it down. So here, okay, here water vapor is there. Here vapors are there here. Now it is at now, so say it is now 120, it is also 120. Here water vapor is there. Right? Now wait for some time. Let it cool to say 180 degree. Don't give it, wait it for some time. As it cools to 80 degree, then anyhow it will stop boiling only. At 80 it stop boiling. Right? Okay, what you have to do? Now pour some ice cold water here. I am pouring some ice cold water here. I am pouring some ice cold water. As I pour some ice cold water, then what will happen? Here water molecules are in vapor state now. They are very free. H2 molecules, no hydrogen bond there, they are free, they are in steam here. So when I put here ice cold water, those H2O molecules, they condense, they come close, they condense, they form water drops. As this vapor condenses, they convert into water drops. Here pressure of vapor, here pressure here, whatever pressure this vapor creating on the surface of this water, that pressure decreases because here this vapor is there, no? That vapor is actually creating pressure here. That vapor, what will happen? Converts to water. This droplet, as this vapor condenses, as it converts to droplets, then here what will happen? Pressure decreases here, the water drops, and some water drops even they fall. Here the vapor decreases, here content of vapor decreases, then automatically pressure on the water surface decreases. As here even this is closed here. Even I am not allowing atmosphere to play its part. Here whatever this vapor was there, that is only applying the pressure on water surface. So this anyhow it is condensed, and here the vapor content decreased now. So they are converted into water droplet, and so they again back to the water. So here the pressure decreases on the water surface. As the pressure on the surface of water decreases, you will find here automatically it start to boil. Here it start boiling starts now. Boiling starts even at 80 degree. As pressure becomes even less than the 1 atm, then water may even boil at less than 100 degree, even at 70 degrees, say 20 degrees, 30 degree, like that. Even water can boil even at less than 100 degree if pressure is less than 1 atm. Here pressure, here atmospheric pressure is not playing its part. Here whatever vapor form of pressure, that only applying a pressure. If that is also vapor condense and forms water, here the vapor decreases and its pressure on the water surface decreases. Then ultimately the water start to boil again. This concludes what you can say. So what we can say, as we decrease the pressure, then automatically boiling point also decreases. What you can conclude from this one? As decrease in pressure, decrease in pressure, decrease in pressure, decreases boiling point. Boiling point. This is there, right? Now you can understand why it is difficult to cook at the mountains, at the peak of mountains. Why it is difficult to cook? You can understand now. At the peak of mountain, at the mountain places, pressure is less than sea level, pressure is less than 1 atm. As pressure is less, then automatically water boils at less than 100 degree. Then here suppose this is water. If pressure is less than 1 atm, at the mountain place pressure is less. So water even start to boil at 80 degree only, it start boiling. Then any food grains if you put here, vegetables and all if you put here, water maximum, what is the temperature of water? Suppose 80 degree. Because pressure is very less, it's boiling at 80 degree only. Okay, depending on pressure, there will be 90, 70, something different at the temperature where it will be boiled. Let us take example here, 80 degree it is boiling. Here pressure is less than 1 atm. If any food grains or vegetable if you put there, then what will happen there? It is inside the 80 degree only, hardly what temperature where the vegetables are there in 80 degree. Right or not? 80 degree corresponding energy is there in the water. 80 degree temperature corresponding internal energy is there in the water. That much energy only it is being supplied to these vegetables. Right or not? Okay. So 80 degree temperature water is providing lesser energy to the vegetables. You can understand, you can put your finger inside the 100 degree, you can put your finger inside the 80 degree. When you will feel more burning sense. When you put it inside the 100 degree, you will feel more burning because you are receiving plenty of energy your finger is receiving. Then what energy you are receiving if you put your finger in 80 degree? 80 degree temperature water provides less energy to the vegetables than what energy 100 degree temperature water provides. So that's the reason. Suppose conversely, in pressure cooker, what will happen? In pressure cooker, so what will happen? Pressure increases. Volume is fixed, pressure increases. As pressure increases, you have already learned. As the pressure increases, boiling point also increases. Then inside the pressure cooker, the water will boil at 120, 130 degrees, something like that. So the water is at high temperature, right? Or so 130 degree. Then anything if you put it, it will receive more energy in a given time. So it will cook very easily. Within short time, it will cook. That's the reason. So at the mountains, it is difficult to cook because lower the pressure, lower the boiling point. And right at the at mountains, pressure is low, so boiling point is also low. This creates difficulty. This creates difficulty in cooking because it takes longer time. It takes very longer time, and even sudden amount of energy is that food material is not received. The other one is pressure inside pressure cooker. Pressure inside pressure cooker is more, so boiling point is also more. So in short time, in short time, vegetables are cooked. Right? This is there. Okay. The next concept here, let me take latent heat. Latent heat. Here, the name here latent is hidden. Hidden. Let me take one matter, one any substance. Suppose its mass is 1 gram. 1 gram. Suppose it is solid. See here, to change its one state to another state, suppose it is solid, to change it to liquid. Okay, solid to liquid you want to change, the temperature of that substance must be melting point. So at one constant temperature, suppose if you are going from solid to liquid, that temperature is a melting point. At one constant temperature, so you want to change it from one state to another state. And suppose you want to change it from one state to another solid, if it is there, you want to go to the liquid. You want to change one to another. Whatever heat you will give from one state. Suppose you have taken one unit mass. What is here? Unit mass. 1 gram of mass I taken. You want to change its state from solid to liquid. Okay. So at one constant temperature. What is that constant temperature where one state can be like solid to go liquid if you want to convert? What temperature will happen? At melting point. So at that melting point, whatever heat you give for changing from one unit mass of solid to unit mass of liquid, that is we call latent heat. Whatever heat you give. Whatever heat you give, no, that heat itself we call latent heat. What is latent heat? Latent heat. What is this? The latent heat, amount of heat required to change the unit mass of a substance from one state to another state. This is called latent heat. What is latent heat? It is the amount of heat required to change one state to another unit mass of a substance from one state to another state. This whatever heat required we call it is latent heat. So this latent heat, it depends on material. For different it will be different material, but it will be different. Okay, this is there. So this is how do we define latent heat? For definition, I will write For unit mass, L latent heat amount of heat is required. For M mass, suppose you have got M mass. For 1 gram, this much heat, L amount, what is the latent heat amount of heat required to change its state from one state to another state? Suppose M mass like 10 gram, 20 gram, something like that, then amount of heat required is, for 1 gram, latent heat is required. For M gram, how much is required? M into L. So amount of heat required to change one state to another state of a given mass of a body is Q amount of heat is required. M is the mass of body, L is the latent heat of that body. What is latent heat? It is the amount of heat required to change unit mass of a substance, unit mass of a substance from one state to other at constant temperature. And understood pressure is also required constant. We feel pressure is constant. Actually, pressure is also required constant. Latent heat of fusion is there, vaporization is there, and some graphs are there. In detail regarding latent heat, in the next class we'll go now. Okay, in the next class we'll see detail about the latent heat. Why it is called latent? Whatever amount of heat we give, no, that heat is never exhibited as an increase in the temperature. Heat given is used for breaking the bonds. During the change of state, heat given is used to only break the bonds, not to increase the temperature. So we feel the heat given where it has gone, no response in terms of change in temperature. We feel is it hidden inside? That is the reason it is called latent heat. This is the amount of heat used to change the state, not to increase the temperature. Okay, many more things will follow in this latent heat. This is just an definition of latent heat. In the next class, we'll see the next part of latent heat. Thank you. Any doubts you can ask. Okay, students, ಕನ್ನಡದಲ್ಲಿ ಒಬ್ಬರು ಕೇಳಿದ್ರು ಪ್ರೆಷರ್ ವಾಟರ್ ಮೇಲ್ಗಡೆ ನಾವು ದಿಸ್ ಈಸ್ ಇದು ಒಂದು ವಾಟರ್ ಸರ್ಫೇಸ್. ಓಕೆ, ಇಲ್ಲೆಲ್ಲ ದಿಸ್ ಈಸ್ ವಾಟರ್, ಇದು ವಾಟರ್. ಓಕೆ ಓಕೆ ನಾವು ವಾಟರ್ ಮೇಲ್ಗಡೆ ಈ ಸರ್ಫೇಸ್ ಮೇಲ್ಗಡೆ ಏರ್ ಪಾರ್ಟಿಕಲ್ಸ್ ಪ್ಲೆಂಟಿ ಆಫ್ ಏರ್ ಪಾರ್ಟಿಕಲ್ಸ್ ಇರ್ತಾವ, ಬಹಳಷ್ಟು ಏರ್ ಪಾರ್ಟಿಕಲ್ಸ್ ಇರ್ತಾವ. ಆ ಏರ್ ಪಾರ್ಟಿಕಲ್ಸ್ ನಿಂತ ಮೇಲ್ಗಡೆ ಇಲ್ಲಿ ಪ್ರೆಷರ್ ಆಕ್ಟ್ ಆಗ್ತದೆ. ಪ್ರೆಷರ್ ಇದು ಯಾವ ಪ್ರೆಷರ್? ಇದು ಅಟ್ಮಾಸ್ಫಿರಿಕ್ ಪ್ರೆಷರ್. ಏನಂತ ಕರಿತೀವಿ ಇದಕ್ಕ? ಅಟ್ಮಾಸ್ಫಿರಿಕ್ ಪ್ರೆಷರ್. ಅಂದ್ರೆ ಏರ್ ಪಾರ್ಟಿಕಲ್ಸ್ಗಳು ತಮ್ಮ ವೇಟ್ ನಿಂತ ವಾಟರ್ ಮೇಲೆ ಒಂದು ಫೋರ್ಸ್ ಕ್ರಿಯೇಟ್ ಮಾಡ್ತಾವೆ. ಆ ಫೋರ್ಸ್ ಆನ್ ಏರಿಯಾ ಅಂತ ನಾವು ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ರೆ ಅದು ಪ್ರೆಷರ್ ಅಂತೀವಿ. ಆ ಪ್ರೆಷರ್ ಆಕ್ಟ್ ಆಗ್ತದೆ ಇಲ್ಲಿ ವಾಟರ್ ಸರ್ಫೇಸ್. ಹೌದಾ? ಓಕೆ. ಈಗ ನಾನೊಂದು ಎಕ್ಸಾಂಪಲ್, ಇದು ನಂದು ಈ ಹ್ಯಾಂಡ್ ಏರ್ ಪ್ರೆಷರ್, ಇದು ವಾಟರ್ ಸರ್ಫೇಸ್, ಇದು ಏರ್ ಪ್ರೆಷರ್. ಹಿಂಗೆ ಮುಚ್ಚಿಬಿಟ್ಟ, ಇದು ಈ ಹ್ಯಾಂಡ್ ಏರ್ ಪ್ರೆಷರ್ ಕ್ರಿಯೇಟ್ ಮಾಡ್ಲತ್ತ, ಇದು ವಾಟರ್ ಸರ್ಫೇಸ್. ಈ ಟೈಪ್ ಮುಚ್ಚದಂದ್ರೆ ಈ ಹ್ಯಾಂಡ್ ನಿಂತ ಯಾವುದು ಮಾಲಿಕ್ಯೂಲ್ ಬರ್ಲಾರ್ದಂಗೆ ಇದು ಕಂಟ್ರೋಲ್ ಮಾಡ್ತದೆ. ರೈಟಾ? ಇದು ವಾಟರ್ ಸರ್ಫೇಸ್ ಅದ. ಈ ವಾಟರ್ ಸರ್ಫೇಸ್ ನಿಂದ ಈಗ ನಾವು ಟೆಂಪ್ರೇಚರ್ ಕೊಟ್ಟೆವಪ್ಪ ಅಂದ್ರೆ ವಾಟರ್ ಮಾಲಿಕ್ಯೂಲ್ಸ್ ಏನಾಗ್ತದೆ, ವೈಬ್ರೇಷನ್ ಚಾಲು ಆಗ್ತಾವ. ವಾಟರ್ ಮಾಲಿಕ್ಯೂಲ್ ಮ್ಯಾಲೆ ಬರ್ಬೇಕಂತ. ಹೀಟ್ ಕೊಟ್ಟೆವಪ್ಪ, ಟೆಂಪ್ರೇಚರ್ ಇನ್ಕ್ರೀಸ್ ಆಯ್ತು ಈ ವಾಟರ್ದಂದ್ರೆ ಈ ವಾಟರ್ ಮಾಲಿಕ್ಯೂಲ್ದು ವೈಬ್ರೇಷನ್ ಎನರ್ಜಿ ಹೆಚ್ಚಿಗಾಗಿ ಅವು ಸರ್ಫೇಸ್ ನಿಂದ ಹೊರಗೆ ಬರ್ಲಿಕ್ಕೆ ಟ್ರೈ ಮಾಡ್ತಿರ್ತಾರೆ. ಯಾವಾಗ ನಾವು ಈ ಹೊರಗಿಂದ ಅಟ್ಮಾಸ್ಫಿರಿಕ್ ಪ್ರೆಷರ್ ಅದ್ರ ಮೇಲೆ ಇದ್ದಾಗ ವಾಟರ್ ಪಾರ್ಟಿಕಲ್ಸ್ ಹೊರಗೆ ಬರ್ಲಾರ್ದಾಗ ಇದು ತಡೆದಿಡುತ್ತೆ. ಈಗ ಒಂದು ಟೈಮ್ ಹಿಂಗ್ ಬರ್ತದ, ಇದು ಹೊರಗಿಂದ ಈ ಅಟ್ಮಾಸ್ಫಿರಿಕ್ ಪ್ರೆಷರ್, ಈ ವಾಟರ್ದು ಟೆಂಪರೇಚರ್ 100 ಡಿಗ್ರಿ ಬಂದಾಗ ಈ ಹೊರಗಿನ ಪ್ರೆಷರ್ ಅಂತೂ ಏಟದ ಅಟ್ಮಾಸ್ಫಿಯರ್ 180 ಅಂತ ಕರಿತೀವಿ. ಹೊರಗಿಂದ ಅಟ್ಮಾಸ್ಫಿಯರ್ ಪ್ರೆಷರ್ 180. ಒಂದು ವೇಳೆ ಈ ಟೆಂಪರೇಚರ್ ವಾಟರ್ದ 100 ಡಿಗ್ರಿ ಬಂದಾಗ ಇವು ವಾಟರ್ ಮಾಲಿಕ್ಯೂಲ್ H2O ಮಾಲಿಕ್ಯೂಲ್ ಏನೋದಿಲ್ಲ, ಈ H2O ಮಾಲಿಕ್ಯೂಲ್ ಮ್ಯಾಲ ವಾಟರ್ ಸರ್ಫೇಸ್ ಮ್ಯಾಲ ಆ ಒಂದು 100 ಡಿಗ್ರಿನಾಗ ಅದು ಕೈನೆಟಿಕ್ ಎನರ್ಜಿ ಭಾಳ ಇರ್ತದೆ. H2O ಅವು ಏನ್ ಮಾಡ್ತಾವ, ಮೇಲಿಂದ ವಾಟರ್ ಸರ್ಫೇಸ್ ಏರ್ ಪ್ರೆಷರ್ ಏರ್ ಮಾಲಿಕ್ಯೂಲ್ ಇರ್ತಾವಲ್ಲ ಅವಕ್ಕೆ ಹಿಂಗೆ ಡಿಕ್ಕಿ ಹೊಡೆದು ಇದ್ರದ್ದು ಪ್ರೆಷರ್, ಇದೇನ್ ವೇಪರ್ ಪ್ರೆಷರ್ ಇದು ಬಂದು ಇವೆಲ್ಲ ಮಾಲಿಕ್ಯೂಲ್ ಮೇಲೆ ಬರ್ತಾವ. ಯಾವಾಗ 100 ಡಿಗ್ರಿನಾಗ ವಾಟರ್ ಮಾಲಿಕ್ಯೂಲ್ ಮೇಲೆ ಬರ್ತಾವ. ಅವಾಗ ಈ ವಾಟರ್ ಮಾಲಿಕ್ಯೂಲ್ ಏನ್ ಮ್ಯಾಲ್ ಬರ್ತಾವಲ್ಲ ಅದು ವೇಪರ್ ಪ್ರೆಷರ್ ಅಂತೀವಿ. ಅವು ವಾಟರ್ ಸರ್ಫೇಸ್ ನಿಂದ ಮ್ಯಾಗ ಬಂದು ಅವಕ್ಕೆ ಒಂದು ಪ್ರೆಷರ್ ಕ್ರಿಯೇಟ್ ಮಾಡೋದು, ಅದು ವೇಪರ್ ಪ್ರೆಷರ್. ಆಲ್ರೆಡಿ ಮ್ಯಾಲೆ ಯಾವ್ದು ಪ್ರೆಷರ್ ಅದ? ಅಟ್ಮಾಸ್ಫಿರಿಕ್ ಪ್ರೆಷರ್. ಆ ಎರಡು ಪ್ರೆಷರ್ ಈಕ್ವಲ್ ಆದಾಗ ಆ ವಾಟರ್ ಮಾಲಿಕ್ಯೂಲ್ ಹೊರಗೆ ಬರ್ತದೆ. ಅವಾಗ ಫಾಗ್ ಟೈಪ್ ಅಟ್ಮಾಸ್ಫಿಯರ್ ಅಪಿಯರೆನ್ಸ್ ಕ್ರಿಯೇಟ್ ಆಗ್ತದೆ. ಬಾಯ್ಲಿಂಗ್ ನಡೆದದ ಅಂತ ಹೇಳ್ಬೋದು. ಯಾವಾಗ ಬಾಯ್ಲಿಂಗ್ ಚಾಲು ಆಗ್ತದೆ ಅಂದ್ರೆ ಪ್ರೆಷರ್, ವೇಪರ್ದ ಪ್ರೆಷರ್ ಮತ್ತು ಅಟ್ಮಾಸ್ಫಿರಿಕ್ ಪ್ರೆಷರ್ ಎರಡೂ ಈಕ್ವಲ್ ಆದಾಗ ವಾಟರ್ ಬಾಯ್ಲಿಂಗ್ ಸ್ಟಾರ್ಟ್ ಆಗ್ತದೆ. ರೈಟಾ? ಈಗ ನಾನು ಆಲ್ರೆಡಿ 2 ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್ ಮಾಡಿ ನೋಡಿದೆ. 2 ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್. ಈಗ ನಾನು ಸ್ಟೀಮ್ ಔಟ್ಲೆಟ್ ಓಪನ್ ಇಟ್ಟಾಗ ವಾಟರ್ ಒಳಗಡೆ ಪ್ರೆಷರ್ ಅಟ್ಮಾಸ್ಫಿರಿಕ್ ಪ್ರೆಷರ್ ಇದೆ, ಯಾಕಂದ್ರೆ ಸ್ಟೀಮ್ ಔಟ್ಲೆಟ್ ಓಪನ್ ಅದ. ಪ್ರೆಷರ್ ಆನ್ ದಿ ವಾಟರ್ ಸರ್ಫೇಸ್ ಇಸ್ ಅಟ್ಮಾಸ್ಫಿರಿಕ್. ಈಗ ನಾನು ಒಂದ್ ವೇಳೆ ಸ್ಟೀಮ್ ಔಟ್ಲೆಟ್ ಕ್ಲೋಸ್ ಮಾಡಿದಾಗ ಏನ್ ವೇಪರ್ ಆಲ್ರೆಡಿ ಫಾರ್ಮ್ ಆಗಿತ್ತು ಅದರಿಂದ ಒಂದು ಎಕ್ಸ್ಟ್ರಾ ಪ್ರೆಷರ್ ಕ್ರಿಯೇಟ್ ಆಗಿ ವಾಟರ್ ಎಕ್ಸ್ಟ್ರಾ ಪ್ರೆಷರ್ ಕ್ರಿಯೇಟ್ ಆಗಿ ಪ್ರೆಷರ್ ಹೆಚ್ಚಿಗೋದ್ರಿಂದ 100 ಡಿಗ್ರಿ ಮೇಂಟೈನ್ ಮಾಡಿದ್ರು ಬಾಯ್ಲಿಂಗ್ ಸ್ಟಾಪ್ ಆಗ್ತದೆ. ನಾನು ಈಗ ಆಲ್ರೆಡಿ ಒಂದೊಂದ್ಸರ್ತ ವಿಡಿಯೋ ರಿವೈಂಡ್ ಮಾಡಿ ನೋಡ್ರಿ. ಏನಿಲ್ಲ, ಪ್ರೆಷರ್ ಹೆಚ್ಚಿಗೆ ಮಾಡಿದೆ ವಾಟರ್ ಸರ್ಫೇಸ್ನಾಗ ಅಂತಂದ್ರೆ ನಾವು ಅದ್ರದ್ದು ಬಾಯ್ಲಿಂಗ್ ಪಾಯಿಂಟ್ ಎಲಿವೇಟ್ ಆಗ್ತದೆ, ಬಾಯ್ಲಿಂಗ್ ಪಾಯಿಂಟ್ ಇನ್ಕ್ರೀಸ್ ಆಗ್ತದೆ. ಮೋರ್ ದಿ ಪ್ರೆಷರ್ ಅಪ್ಲೈಡ್ ಆನ್ ದಿ ವಾಟರ್, ಮೋರ್ ದಿ ಬಾಯ್ಲಿಂಗ್ ಪಾಯಿಂಟ್. ಓಕೆ, ಬಾಯ್ಲಿಂಗ್ ಪಾಯಿಂಟ್ ಹೆಚ್ಚಿಗೆ ಯಾವಾಗ ಆಗ್ತದೆ ಅಂದ್ರೆ ಪ್ರೆಷರ್ ಅಪ್ಲೈಡ್ ಆನ್ ದಿ ಸರ್ಫೇಸ್ ವಿಲ್ ಬಿ ಮೋರ್. ಕಮ್ಮಿ ಯಾವಾಗ ಆಗ್ತದೆ? ಪ್ರೆಷರ್ ಆನ್ ದಿ ವಾಟರ್ ಸರ್ಫೇಸ್ ಕಮ್ಮಿ ಇದ್ದಾಗ ಬಾಯ್ಲಿಂಗ್ ಪಾಯಿಂಟ್ ಕಮ್ಮಿ ಆಗ್ತದೆ. Right? This is some basic. So once again you revise it and see. So you will come to know as pressure decreases, boiling point decreases, pressure increases, boiling point increases. Right? So main thing is the quarreling between atmospheric molecules and H2O molecules. If this H2O molecules, this vapor molecules pressure becomes equals to atmospheric pressure, then water molecules can go out. Then the boiling is said to be occurred. Dear student, latent heat, just introduction I given, it is the amount of heat required. I told you for it's proceeding things I'll tell you in the next class. Suppose this is on any matter substance, its mass is 1 gram, 1 gram. Suppose it is solid, okay. So to change it solid to completely liquid, right? At its melting point ಅಂತಿರುತ್ತೆ ಪ್ರತಿಯೊಂದು for all substance there will be one melting point. At its melting point, suppose the unit mass, suppose its mass is 1 gram, unit mass of a solid substance, to change it, unit mass of a liquid at melting point. The what to do so, whatever heat we give now, that heat is called latent heat of fusion. So generally if we speak, this is the definition. What is general definition? It is the amount of heat required to change unit mass of substance from one state to another state at constant temperature. It's a general definition. When it comes to fusion, vaporization, just I'll tell you in the next class. What is general? It is a quantity of heat required to change from one state to another state. So we have one criteria, standard criteria of unit mass. Unit mass, whatever heat you want to, you are required to give to change its state from one state to another state at one particular temperature, constant temperature. That amount of heat what you give is called latent heat. So please just tomorrow's class in detail again, latent heat of vaporization, fusion, then again you can ask the doubt, right? Okay.